Hey friends, today I'd like to talk a little bit about OT and IoT security, ICS security, really Internet of Things, operational technology, uh, security of PLC or programmable logic controller devices that you would see on a factory floor, controlling pumps or gauges or other, factory automation. This is all technology which has been heavily used for the last like 30 years. And automation in a factory is important. It's absolutely necessary. It's used in energy and healthcare and a lot of other places too. But most of these don't get patched and aren't properly secured. Most of them were created before security was even a question. If you think about really security as it's evolved in the last 5 to 10 years, most PLC and automation equipment is older than that. That's out there in the field. Newer stuff is taking security into consideration, but most stuff that's actually out there is much older, and a lot of the companies that have made the equipment are out of business now. Equipment speaking old protocols is hard to secure. There aren't any patches available. And even on the stuff that is by a vendor that is currently in business, a lot of times those are end of life now. And, Siemens or Honeywell or whoever may have a new device that they're selling. They're not supporting the old one. Security architecture with ICS is really a thing. And, Purdue has a model for ICS security, which is kind of a tiered architecture. That is a good approach to it. Also layering in some zero trust. A zero trust approach would be a good idea. So I like the Purdue model because, you're really separating your control plane from your devices, and from your production network. And I like the idea of micro-segmenting from there. So adding some zero trust ideas where you're using IAM and, to control your identity and access management, to control what devices and users are able to access what devices on the network, and then micro-segmenting them. So, the conveyors PLC stuff may not have to talk to the stuff on the pumps, PLCs. So why not just segment them, micro-segment them down using the network or using software? But I like using the network and then routing all of the traffic from between those segments through a segmentation gateway, which is a zero trust concept. But if you think about a firewall, with, IPS enabled, threat detection enabled, think of a new Fortinet or a new Palo, has all its subscriptions, enabled, and it is actively looking at threat traffic. Now, instead of just controlling the border of your network, which you still want to do, perimeter control, you are making every interaction between every micro segmentation have to go through this inspection at the firewall. Will it add some latency? Yes, a little bit, but you probably won't notice it because these devices aren't like communicating at 10 gig. Like they're communicating small pieces of information, small pieces of telemetry and stuff, frequently, but it's not, you won't notice your latency. Let's put it that way. You will not notice a latency problem. It's not like you're putting this in your SAN. You are not going to experience latency with putting a border, not a border gateway, a segmentation gateway in with threat detection and inspection on all of your inter-VLAN traffic or your micro-segmented traffic, so that if there is communication between these segments, it is going through inspection. And number two, if you're thinking about a zero trust model, you're locking down that communication to what needs to actually happen. So if the conveyor PLC never needs to talk to the pump, then make an ACL so that it can't. Like only allow traffic between VLANs that should have traffic. So if the SCADA VLAN which may be on a TMZ, but may have a backend controller. Let's say that backend controller is allowed to communicate to the conveyor network and to the pump network. Then those ACLs should exist. There should be no ACL then from the front end, DMZ side of the SCADA to those devices. There should be no communication from between those devices, really only from the SCADA to those devices. So what I'm saying is architecture-wise, and what I just said may not work for your architecture. I don't know how your SCADA is set up. You may just have one virtual appliance that is sitting in the DMZ and needs to communicate with everything. To me, that's a problem because, that means somebody hacks that SCADA and they have access to literally everything on your network. I would rather have a web front end or an API service or, a SCADA front end and then, or even a reverse proxy, and then have communication to a back-end device, which is kind of like on DMZ2. And then that is able to access the PLCs, and whatever database it's using for its data, that kind of thing. But so getting a little nerdy here, but it's important. And this is actually what I'm really good at is architecting security solutions and architecting cloud solutions so that they make a lot of sense for you. So in your Purdue model, it is tiered. Still use that, but implement some microsegmentation, some device control, some IAM, some least privileged stuff. Implement these zero trust concepts into your ICS model. And also log everything. Like it's going to be a lot of effort if you have thousands of devices, but collect all of your see if you can set up all of those devices to log to a central SIM. There are companies that specialize in monitoring as like an MSSP, OT environments. I'd recommend using one of those. If not, at least have it centrally managed and monitored and have ASOC looking at it. The reason is any kind of threat traffic will be caught in that as well. And it's nice to be able to look and see when this happened. So something that related that has kind of been known for a while is, China, for years has been in pretty much every manufacturing environment in the U.S. Like they live there. They have APT that are just living in those networks. Usually with the U.S., they're stealing information. They're stealing how our processes work. They're stealing our plans, things like that. They're stealing the designs and the methods by which we're manufacturing these. China is usually not one to, even though they have access to every U.S. manufacturer, is usually not one to be destructive because they're trying to gain information so that they can do it better and cheaper and beat us to market with our own designs. That's a little bit different than other threat actors like Russia, Russian threat actors, North Korean threat actors, Iranian threat actors, etc., which may be on a nation state attack level trying to disable U.S. functionality. So disable our power grid, disable our communications networks, disable our manufacturing capabilities, our banks, etc. Those are different use cases, but it's the same vector of attack. Most of them are attacking our OT networks and our SCADA in order to get into the network. They can fish, if you have your architecture set up right, they can fish you on your production side and not get access to your OT network. But some networks aren't set up properly, so they can, but usually the OT network is highly vulnerable. Usually there are endpoints exposed to the internet, whether it's your SCADA or some other control point. That, for the HVAC, people to get in remotely into your HVAC system and tune it. For your PLC people to come in and update and reconfigure PLCs. There's usually some outside access that is enabled. And that's the same access that the attackers are leveraging in order to gain access to the network. And, once they're in there, they can do a lot of destruction to what you have. And most people aren't backing up their PLC configuration stuff. Most people aren't, it's companies that I've worked with that are manufacturers. It's almost like OT is just a thing that exists and they don't think about it as IT. They don't think about it as something that needs to be managed or secured. It's just, oh, that's the factory. We need to focus on backing up our ERP system and our CRM and stuff like that. But nobody's thinking about the OT environment. Now, if it's set up improperly, an attacker can gain access to the rest of your network through your OT network and then, do whatever, drop ransomware, et cetera, and vice versa, but, what I really want to draw kind of attention to is just that there's a real lack of security on OT and IoT. Think about just even your home network. You have these thermostats, cameras, toasters, smart coffee maker, smart fridge. You may have 150 IPs that are used by smart devices on your home network. How often do you update any of those or patch any of those, if at all? The largest botnets in the world have been made with people's DVRs, their cameras, their home network video cameras that have been set up for remote viewing. So, that is incredibly vulnerable because those tend to be Linux servers. And if they are on your network for 10 years, recording video, then it usually hasn't been patched for 10 years also. So that same kind of thing is what we're seeing with manufacturing. And I use manufacturing as my ICS and OT example because that's what I run into a lot with what I do is manufacturers. But there are a lot of people that use, especially in healthcare and stuff like that are using OT a lot. And in a hospital room, there are several IoT devices. So, each of them are posing their own vulnerabilities and risks. So, there's a lot to consider. But what I'd like to do besides just raise awareness there is really show people that there is some security that can be improved there. If you have a manufacturing environment, let us take some Purdue ICS model concepts, and then let's layer in some zero trust microsegmentation. Yes, it's some work. Needs a new firewall. Needs new VLAN set up in all your switches. Oh, your switches are old and not VLAN compatible. Let's put in new switching. So there may be some expense there, but and some work because now we got to take down your conveyor network in order to re-IP everything. We got to take down your pump network to re-IP everything, your mixers, everything. To put them on the proper VLAN. Test, verify communication. So there's going to be some change management here where you're working one device at a time. Say, okay, Thursday we're changing over the conveyor network. Then next Thursday we're changing over the pump network, and then the following Thursday we're changing over the sprayer booth network, and microsegmenting everything. And then testing as you go, reconfiguring your SCADA to point to the devices correctly on their new IPs, and just working through it. And so it's a big migration project if you have a lot of things on your network, but it's worthwhile to modernize how your network is set up and improve your security there. All right. Well, I hope everybody has a great day. Like, subscribe, drop a comment, whatever. All right. Thanks.